Hey guys, welcome back. This is where we ended up the last one, where you found the direction, which was 32 degrees south of west, and the magnitude here, this C value, which was approximately 47.2. On the next slide, you are finding the speed of the ship, which is your magnitude, and the direction it is traveling. So you're finding this angle right here. Start from the horizontal and moves up. And this is a problem that's coming into me. So this is problem number 2. Okay, to be submitted. And it will follow exactly like we just did over here. Your direction and magnitude. So make sure you can do that. All right, here we go. Another example. A swimmer heads perpendicular to a 3 mile per hour current in the river. Her speed in still water is 2.5 miles per hour. Find the actual speed and direction of the swimmer. So here is what's called the resultant. Okay. Between the two. Excuse me. And we are going to do exactly like we did before. This is 2.5 here and 3.0 here. And to find that x squared, you're going to do 3 squared plus 2.5 squared, just like your Pythagorean theorem. So 9 plus 6.25, which gives you 15.25. We're going to have the square root of both sides, which is going to give me 3.9 miles per hour. So we're dealing in miles per hour. And that is approximate. Okay. So that is your, that's my actual speed of what's going on. My direction now is this angle right here. And we're going to use the tangent again. The tangent of theta is equal to 2.5 over 3. So that means my arctan here is the 2.5 over 3, and it will give me my angle. So, clear arctangent of 2.5 divided by 3, and it gives me the 39.8, roughly. Okay. 39.8, which, if you go with the degree, we got 39.8 rounding off, which is right at 40 degrees, which they usually ask you to do. Okay. Now, if you have the coordinates of the vectors, to get a sum of them, you can simply add them up. 4 plus a negative 1, and then 3 plus 2, which would give you 3, 5. That's going to be your addition. Okay? A plus C here, negative 5 plus 2, then negative 2 plus a negative 5, and that's going to give me negative 3, negative 7. Okay, so that works. If you've got the coordinates, you just add them together and give you your new resultant, your new sum. Whoops. Sometimes you do not have the points. I've got 0, 0 here, but I don't have the points. So if they want you to describe OL as an ordered pair, you will use the sine and the cosine. Because you've got to find your x and your y Don't forget your x is the cosine and your y is the sine. So right here, we've got 50, and that sine of 50 degrees is the opposite y over 65. So y is going to equal 65 sine of 50. Same thing for our x. You've got the, it's not sine of 50, it's cosine of 50, which is equal to the adjacent x over 65. So when you cross multiply, x is going to equal 65 cosine 50. All right, so 65 sine 50 is 49.8. Okay, 49.8. And this 65 cosine 50 is 41.8. Okay, so those right there, the from 0, 0 to that, your coordinates would be 41.8 and 49.8. That would be your component form, your movement horizontally and your movement vertically. And that vertical movement would be a negative because of how you're moving down in this case. Positive x, but a negative y. Okay? Two other ways to add vectors. You've got these, however much that is, head to tail. And right here, the parallelogram method. It's virtually the same thing because you could easily draw a parallelogram right around this. So it's identical. But that's how the vector sum from the resultant. Okay, here's the next example. The swimmer in the previous example changes direction so that she is heading at an angle of 40 degrees west of north. Okay, this whole thing right here. Okay, I was trying to figure out how to fix this because this is not actually correct up here. It says this is 40 degrees west of north, but this is actually, it is 40 degrees north of west. And I don't know how I typed it in the back way. But that thing right there is 40 degrees, the whole thing. I don't know what this angle is, but that whole angle right there is 40 degrees. That makes this 140 degrees because adjacent angles on parallelograms are always supplementary. They add up to 180 degrees. So, what is her actual speed and direction? Well, we got some things we can do with this. I've got two sides and an included angle, which means I can find that resultant c squared is going to be a squared plus b squared, 2.5 squared plus 3 squared minus 2 times 2.5 times 3 times the cosine of 140 degrees. So 6.25 plus 9 minus 5 times 3, 15 cosine 140. I think it's time to break the calculator out now. You're going to have 6.25. Let's do 15 cosine 140 first. All right, that's negative 11 point whatever, plus 9 plus 6.25. Something's wrong. Obviously didn't do that right. Let's see. Mode is degree. I always want to check that. Oh, that's because we had 6.25 plus 9, and then it was minus a negative 11.5. That's what happened with it. So that means it's just going to be added. Okay? So 15 cosine 140 is that. Okay. Plus 6.25 plus 9. And we get about 26.74. So C is going to equal the square root of 26.74. Square root of the answer. And that's going to be about 5.17 approximately. Okay? So, that right there is where C is. And we need to know this direction right here. Okay, well, the sine, we go to that, sine of theta over 2.5 is going to equal the sine of 140 over that 5.17. Okay, so if I cross multiply, then the sine of theta is 2.5 times sine of 140, which is 1.61 roughly, divided by 5.17. So we have 0.3108. So the arc sine here of 0.3108 is my theta. So let me put that answer back in here. Means my theta is about 18.1. So what I have is my direction is 18.1 degrees. And this again is north of west. And the actual speed is about 5.17 miles per hour.